Right then, so I'll get started, put this in full screen mode. And good morning, good afternoon, everyone. My name is Isabelle Mauny. I'm the field CTO at 42Crunch. And we're here to talk about API security and how you can inject security into API development, right? So it's going to be no surprise to any of you that APIs have become, over the years, the number one target for attacks, and this for multiple reasons. First of all, it's a very large source of revenue for hackers. It's a very large market, dark market, but it's a huge market. The data which is being stolen through APIs has a lot of value, so this is not going to stop anytime soon. And if we look at the problems that have been happening, I would say in the past 3 years now, it's almost 3 years since we launched API Security.io, which is our community site at 42Crunch. And there we rarely publish some news and information about breaches and best practices, etc. And if you look at the breaches and the problems that have happened, well, they touch everyone, large companies. Usually they are the ones that make the public news, the large company ones. And if we look across them, you're going to see that usually the problems that are happening, they're all coming from the same kind of source, right? And we don't really validate inputs. We usually don't have rate limiting or badly configured rate limiting. We leak some data. We have authorization, authentication problems, right? Which are the core ones. So we'll get into all of those in a minute. Okay. So much that if we look at all those different problems, in application security, traditionally, we had a list of problems that would be the top problems that would happen to applications that would be a problem. And APIs were not really exposed through that. They were like a kind of an overall problem across all the different problems that the OWASP top 10 would actually be exposing, up to, well, the end of 2019, where we recognize that APIs are different and they have specific vulnerabilities and specific problems, and therefore there is a specific top 10 for that. And I put some color coding in here just to show you there's basically 3 groups of problems. There are problems around access control. In general, that could be authentication authorization. That's the part which is in orange here. The parts about data. So this is very specific about data. Data is really the specificity of APIs, that they're used to expose some data and will accept some data inbound, very much. So everything about controlling the data is very critical, and we will find here injection issues as in the normal, the traditional OWASP top 10, because we still have problems there at that level. It's much lower in priority than it is for normal application security. And then we have traditional issues around more governance and operations, such as logging and configuration of our systems, right? So to illustrate what does it look like and how we tie this to the API one, I just picked up one problem, one massive issue that happened earlier this year in January. This is a massive breach. About 70 terabytes of data were actually stolen. If you're in the US, you have heard, I'm sure, about PARLER. If you're not in the US, you may not have heard about this. Listen, this is a social network for a specific political, it has a very political aspect to it, related to the Trump administration, etc., and what happened there, without getting into more details. But let's say this social network, when it got breached, what they realized is, there was this public API, no authentication at all, that would allow you to go and get any public posts. So any post that would be made on that social network that would have public visibility would be available through the API with absolutely no authentication at all. There was no rate limiting, and this was also using sequential IDs. What that means is every single record of a post within that social network would have an ID, let's say 123, and the next one will be 124, and the next one will be 125, etc. You get the picture. So if I have zero authentication and I have no rate limiting and I can have sequential IDs, it makes very easy to write a little engine that will just poke at the API and say +1, +1, +1, and that's how they got the 70 terabytes of data before the system was actually brought down, right? What else was wrong in here? Well, this system was leaking a lot of personal sensitive data, like the location and a lot of information about the people that were posting the information. And finally, there were also, whenever you wanted to delete something, which in the context and the political context, a lot of people tried to do, which was to delete some of the posts they had put in there. And what really was happening, if you were trying to delete something from there, it will just turn a flag on saying, hey, this has been deleted. But really, it would not actually delete the data. So if you were looking at the data through the UI, when that flag was on, it will say, nope, the data has been deleted, everything is cool. But if you were going straight into the API, all the data was there, right? So this is a typical, problem of leaking information and data, which is the API 3 in that case, and that touches a lot of the authentication and authorization problem that we're going to talk about. This is the only, I think, problem that I know of that I've been looking at for the past 18 months that has 6 of the 10 problems just for this one breach. Maybe they have all the other 4. We don't know. We'll never know. But it's also a very, I would say, common problem that when there are very large breaches like this one, you never have a single problem. It's very rare that you'll have a very large breach where you have only one of the API top 10. It's usually a combination of things that makes it much more impactful than it should be, right? So why is this happening? Why do we have those problems? Well, the first thing is really the architecture of our application has been changing, and we have not changed so much the way that we're looking at the applications and where you have to do all the enforcement of the data and authentication authorization. We used to have, pre-API era, we would have an application where all the logic and business control and everything would be on the server side. And we would there filter out what is the information we will show on the client side. But now we don't do that. Now we expose some APIs and we have very rich clients, and we tend to move that controller logic, for example, which data I'm going to show to client A or client B, not on the server side, but on the client side, which basically means that if I go straight into the API, all that logic, all that filtering logic back to my problem from PARLER, where I had just a delete flag, and the delete, it's just handled on the client side. That's the typical example, right? Then that controller layer is missing, right? So we just get the raw data and we expose that raw data. So that's first an architecture problem. The second one is traditionally application security has been about building walls around ourselves, right? We have a data center, which in this picture here is materialized by the Arc de Triomphe in Paris. And what we would be doing was building walls, like multiple walls around that. So if, some bad actor would go over the first wall, we'll still have a second one and a third one, etc. So make it work very hard to get into the heart of the system. Now, when we create APIs, what do? When we create APIs, we create an avenue all the way to the data, straight to the outside world, right? So this notion of boundaries and walls, that really doesn't exist anymore. We're also consuming a lot of APIs from outside systems, from SaaS, from, so that pure perimeter, very defined and refined perimeter is really gone, right? So really the protection, it's all about what do we do to protect the data. Now, to make things worse, really security is still very much an afterthought. So it is something that we just say, okay, oh, we have to pull out this API, so let's go and see the security guys and see what they can do about this and test it. Usually it happens very late in the life cycle of the APIs, maybe a couple of days before actually release. Oh, that's right, we forgot about the security guys again. So, and it really cannot do any good job in that situation. That's a big problem. And what makes this even worse is that our development is extremely agile today. We have given the development team fantastic tools, frameworks, automated deployment and testing, etc. So they're extremely productive, extremely fast at A, creating new APIs, and B, creating new versions of APIs. But we really haven't equipped the security guys with the same type of tools. So it's really hard for them to keep up with the rhythm at which APIs pop up all over in the data centers and the versioning and changes across the existing set of APIs. So the number of APIs we're actually creating is not helping there. We used to have maybe 5, 10, 20. Now we have hundreds, right? So multiply that by the fact that they're changing often, and it becomes very complicated to scale security and security testing across the company, right? So this presentation is really a call to action. It's like, what can we do about this, right? And I have 3 things for you to do. First of all, we really have to change that mentality of changing and looking at security very late in the life cycle. We're going to look at this now. So the earlier we start, the easier it will be to discover problems and to fix problems. Second is really security must not be an afterthought in terms of we create all the API, we've designed it functionally, etc., and then we decide what security is going to be. That really needs to be something which is part of the design and how you're going to develop and implement this API. And third, we need to start thinking like the byte guys, right? So we tend to think about and test the APIs well, this is how it has to work. This is the functional behavior of that API. That's why it's going to do, right? But we need to think about what happens if this is done or that call is made. So we'll talk about this in more details. But this is like the 3 main things I want to cover now. And starting with design, right? So I don't know who had that fantastic idea of putting a bath at the top of the stairs. But as you can imagine, if somebody wants to buy this house and redo this, that's going to be complicated, right? They're going to have to break everything. So design decisions are really hard to undo. That's why, at design time of your APIs, you have to start thinking about security. And here are some guidelines on how to do that. First of all, in security, everything is about the risk, right? So when you're designing APIs, you have to define what that risk is going to be. And when you design and redesign and evolve your APIs, you'll have to think about this as well, right? So if you design an API for internal consumption and you take that one and 6 months down the line, it's now exposed to Jodo, to anywhere on the internet, that's not the same risk. You need to redefine that risk. You need to redefine how that API is going to be secured, right? So is this an internal API? Is it an external API? Is it maybe it's open only to administrators. So who are the consumers, partners, whatever it is? But you need to understand who is going to consume this. Then what is the data we're going to expose? Is it sensitive data? Do we have PII in there? Maybe because it's extremely sensitive or the way we're going to consume this, maybe we need to sign, maybe we need to encrypt that data. Those are things you need to think about before you start writing any code, because again, when you start writing code, some of these things, or if you are done writing the code, adding this type of information on top and trying to change the implementation because you made a by design decision and you didn't think about this when you did the design, is going to cost you, 10, 20 times more than if you think about it earlier, right? So that's the first thing. What's the risk? What is the data? The second thing is we have to define our interface. So, okay, maybe we take an API design first approach. We start writing the interface of our API. So this is where the decisions about some of those top 10 are going to become critical. So who has access to this and under which conditions? So this is all about authentication, authorization. Again, what are my operations? What are the actors? And how are we going to access this information, the operation in my APIs? Think about all the resource IDs. Again, I see a lot of customers who are really blocked by this, because if you go back to this PARLER, and this has happened to Uber and many other people, because this is API 1 and it's the #1 problem, is about this. I'm exposing some information. Let's say I'm Isabelle. I can do get account details on account 1, 2, 3. Okay. But if I'm trying to access account 4, 5, 6, that's not mine. It's the same operation. It's still get account details, right? But it's 1, 2, 3 versus 4, 5, 6, whatever I said. So somewhere along the lines, we should really not use such easy IDs to guess, right? So this is going to help you mitigate the problems around this IDOR, BOLA, broken object level access that API 1 describes. It's all about making sure that Isabelle cannot access 4, 5, 6. It can only access 1, 2, 3, right? So design those resources. How are we going to manage them? What format will they have? Most likely what you want is more like GUI IDs, like this 36 characters long thing, which are pretty much impossible to guess. But again, if you try to change this post, that's going to be pretty much impossible to do. It's very hard to put a patch on top of this once all the design and the implementation is done, right? Very important, data structures. So in security for APIs, there's a lot of problems. There's 3, there's 6, there's 8. They're all around, what is the data we're returning? What is the data we're accepting? How do we manage to not be vulnerable to any type of injections, which is API 8? To make sure that you're not, sensitive to this kind of vulnerabilities, managing the data and validating the data that you're either receiving or returning is very critical. You need to own those data formats. That could be your JSON structures, your XML structures, I don't care. Your maybe, gRPC protobufs. All of these are data structures that you need to describe properly and that you need to enforce, no trust there. Again, every time that there is something that comes my way, by definition, I'm going to validate it. Doesn't matter where it came from, okay? And finally, admin operations. This is, what are the operations we're going to allow? Where are they? Who can access them? So maybe this is actually a different API. Again, all this, design of what API does, how we administrate the data, etc. That's all good decisions we have to make, which have a direct link in potential future vulnerabilities that can be introduced. And finally, operations, right? Login monitoring, I cannot stress this enough. Login monitoring is not something you can put on top of your APIs at the end of the development. That is not going to work. You're not going to go back to thousands of lines of code and start putting some logging and monitoring. You have to think about that at the beginning. There needs to be some framework that can be reused across the board, across all the APIs. You need this also for observability, right? Again, not something you're going to decide at the end of the lifecycle. And this is critical for security, for forensics, for understanding what's going on, maybe for detections of patterns. You need that information. Same thing for rate limiting. Rate limiting is not something you just plug on top of something at the end of everything. No, you have to design it, maybe for authentication operation, for authorization operation, for very sensitive operation. This needs to be designed. How are we going to rate limit and based on what, right? And finally, versioning. That's also something you need to think about. What is going to happen when we bring version 2, version 3? How are we going to retire version 1? Again, all things like if you don't have the mechanisms in place to do it, then it was going to be very hard to do. And then what happens? Well, we forget about version 1 and we keep it there on a corner because we forgot to retiring it. And version 2 is the one everybody should be using, but version 1 is still there. And boom, it's being abused because we don't care about it anymore. We don't even monitor it. And it's become a vulnerability to get into our system, right? So you have to think about all this. Now, this is the Ask conference. So what's the relationship with OpenAPI and specifications in particular? Well, where OpenAPI and OASINC API can really help here is by helping you will have a standard language for defining and describing what your API is actually doing. So that you have this one file that describes, hey, this is what my API does, this is all the operations, this is all the data. And then, what used to be something a few years ago that was only written maybe after the fact for documentation purposes, now there is this huge ecosystem around it that really allows us to, design our API, create mockups, create testing, documentation, etc. And maybe even more importantly, from a security standpoint, enable an approach that we call a security as code. What does that mean? That means that we can express the constraints around our data and around those, potential vulnerabilities using OpenAPI. A static definition of something, it allows you to, put that in the code repo. You can track the changes. You can track, who has adding an operation, remove something. We have an audit trail of all that. We can version. So now this definition, and I have a lot of customers that I have, even without, looking at what they do with 42Crunch, have been putting their own extensions in there. Gateways do that as well. So they can express, and that's the fantastic thing about OpenAPI is it's extensible. You can create your own ACME, extension that you can then consume from a CI/CD and do some automatic things from, right? So that enables you to take a positive security model approach. And if I just explain quickly what that means, normally in security, for many years, we've been looking at taking a negative security approach, which is very much threat-centric. And in a negative security model approach, we just worry about the things we want to block. We worry about the things that we don't want, right? So we let everything in and we'll look at the traffic. And if something we don't like, then we just basically stop it. And that works out of patterns and maybe lexical recognitions and regular expressions and all this cool stuff, right? Now, in the API world, and that's really a great thing about OpenAPI or something like async API, we have the ability to describe what is the traffic we're actually expecting and what does it look like. So now we can say we're going to close down on everything but what that file actually describes. That allows us to just have access to approved traffic. So this is about trust. It's not about threats anymore. So we don't care if there are new threats. We care about this is what our API does, and that's what we're going to allow in because that's what we have defined, and we don't care about anything more, right? So we want to define what is expected and reject everything else. That's what we're going to put in there, how things are authenticated, authorized, all of that can be expressed, including the data that comes in and out of our API, right? So if we look at the OpenAPI definition, we have, so those security schemes, what is the security that is enabled? What are the parameters? What are the data formats? We're working now on extensions to OpenAPI as part of I was just on this panel on the special interest groups. We have special interest groups, the SIGs, on SLAs, on security, on workflows. So you can really have all this information, again, in a single file that allows you to really automate things. And that's the big thing. Remember that scaling problem that I was mentioning at the beginning? The only way we're going to address scaling is because we have automation. So this information we have in those files, it will allow us to automate, enforce some specific maybe rules and security rules within your company. Like, is it okay to have an API key or auth for your APIs? Is it okay to have basic auth? Right, all of that it's described. I get through my CI/CD, boom. No, you can't do basic auth because that's not right. We don't do this in this company, right? I can automatically test my API, and I'll give you some examples of tools that do that now. I can really have data governance because all my data is described as part of that file as well. So this is like an additional usage of OpenAPI from maybe on top of what you are already doing. There is a full set of security things that can be done and automated through the usage of OpenAPI, right? Automated testing, automated attachment of policies, automated deployment of protection. We can do all of that just by consuming an OpenAPI file, right? So what kind of tools do we have at our disposal here? So at 42Crunch, we have, first of all, a tool that allows you to audit this OpenAPI file quality and hardening. We call it audit. You can go and test it. I have a reference page at the bottom of this presentation where you can find a link on how to do that. If you may have heard of a project more than a product from the OWASP called ZAP. What this will allow you to do is to do fuzzing from OpenAPI. So you can do this automated testing. You can put ZAP in your CI/CD pipeline, and what it will do is it will start bombarding your API with all kind of bad data and injections and stuff like this, and see how your API is actually handling that. Staghawk is kind of a ZAP++ based on the same project. Microsoft Wrestler is very interesting as well for doing REST API testing, or also around security. Yelp has issued a very interesting project about a year ago called Fuzzlighter, a cool name too, which allows you to test for those IDOR Ebola issues. So you can kind of write your own test on top of their framework. And what it will do is it will do this incremental sequential IDs. It's just to make sure that if you don't put the proper IDs in there, then if you put improper IDs in there, you will actually be rejected, right? And also, again, on 42Crunch, we also have some dynamic testing to allow you to make sure that the implementation of your API actually conforms to whatever the contract is saying. So those two are always in sync, right? All of this is doing, security testing along this OWASP top 10. So what you want to do really is to automate all of this, right? And my call to action really is this. As I hope I showed you in this presentation, there's a lot of things that in decisions you're going to take at design and development time, which are going to greatly impact how secure your API is going to be, right? And anything you're going to discover at production time is going to cost you a lot of time and effort and energy and money to actually fix, if possible, because that's the other thing, right? There's some design decisions that are really hard to undo or rewrite. Maybe it's just like, okay, this is version 2, version 3. We just grabbed the previous version we had and we have to rewrite the entire thing. Can you do that? Is that something that is feasible in the accelerated market in which we are, where everything has to happen for yesterday? That might be a big problem. The sooner you look at these problems, the better it's going to be for you, right? And then hack yourselves. So this IDOR problem, those authentication problems, those authorization problems, those, accepting too much data, leaking too much data. The only way you're going to discover any of those is by automated testing, negative tests that you have to do, where you send some bad data, bad tokens, bad users, anything your API must not accept. If you don't do this yourself, it will be done by somebody else, by bots, etc. Right? So be careful and just carve some time in your testing for this kind of things, right? And again, you have to automate. There is no way. I'm sure you're listening here and none of you have 1, 2, or 3 APIs. All of you have dozens, hundreds of APIs that you have to secure and work with, right? If you don't automate through the tools, through CI/CDs, etc., it's going to be very, very hard for you to scale your security. And frankly, it's going to very badly affect API quality even, right? So it really is something you have to collaborate on. That sentence here on the right for me is very example. Security is not the problem of security people. Security is a problem of the entire team working. So it's a development problem. It's a security, of course, problem. It's also an ops problem. And we'll really have to work all together to make security better, right? And that concludes my session for today. If you basically go to our virtual booth and pass by, you have the opportunity to win this great portable waterproof speaker. And I'll stay on for a few more minutes on the Q&A if you have any. Thank you very much for attending this, and you have a great rest of this fantastic conference. Thank you very much. Have a great day.